Hello everyone, welcome to my chemistry channel B.L.DASH Short and Sweet in Chemistry. Also, I want to welcome the students of Life and Science for the topic Isomerism in few hydrocarbons. Actually, in 11th class, the hydrocarbons are specially alkane, alkene, alkyne and benzene. Now we'll see the part 3 Isomerism in hexane. Then what is hexane? Hexane is one type of uh, alkane having 6 carbon. Now what is the alkane formula? CnH2n plus 2, where N is the number of carbon. And so we will see here what is the formula of hexane, that is C6H14. Then come to question, what is alkane? Alkane is one saturated hydrocarbon that is called also parent hydrocarbon, also called paraffins because they are inactive. Now what is meant by isomerism? Isomerism means the same molecular formula but different type of arrangement of atoms. So same molecular formula but different arrangement of atoms. So here in alkane, generally what type of isomerism is possible? And actually in alkane, only chain isomerism possible, though there are so many isomerisms are there in hydrocarbons. Now in chain isomerism, only the branch will change and there is no other changes, because this is simple straight chain or simply chain structure of alkane. That means here alkane only shows chain structure, and here you can see what is the formula of hexane, C6H14 according to the general formula of alkane, CnH2n plus 2. Now first is CH3, CH2, 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 see count here, 1, 2, 3, 4, 5, 6. That means first you write CH3 and last you write CH3. In middle how many remains? That is 4 carbon. Then 4 carbon by 2 hydrogen, that is CH2. If you attach CH3 by 4, 1, 2, 3, 4 carbon with 2 hydrogen, and last one you put CH3. It is very easy for writing N-hexane structure. That means CH3, CH2, 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 CH3. This is called N-hexane. Then come to second one. See second one, what I have changed here, I put in the form of iso. So I told if CH3, CH, CH3, the group is attached to first from the beginning, then is called iso structure. Now CH3, CH, CH3, that is iso. If iso word you will use, then you will see how many carbon atoms totally present. 1, 2, 3, 4, 5, 6. So it is called isohexane, that is common name. And what is the IUPAC name? In IUPAC name, you will select the longest chain. Yes, from this side, 1, 2, 3, 4, 5. If you count from this side, 1, 2, 3, 4, 5. In 2 positions, there is a methyl group. In 2 positions, there is a methyl group. If you count from this side, 1, 2, 3, 4 position methyl group, which one is correct? Actually, the substituent was present nearer to N, and that is correct. And from this side, we will count number 1, 2, 3. So it is 1, 2, 3, 4, 5. That means 5 carbon, that is the longest chain. And in which position CH3 attached? 2 position. That means 2 hyphen methyl, M should be capital, pentane, because the long chain having 5 carbon, and that is pentane, 2-methyl pentane is the correct IUPAC name. Now other one if you want to see, here one structure is there, first CH3, second CH3. You always remember when you write, you are going to write the structure, first CH3 put and last CH3 put, according to the name you write the structures. 1, 2, 3. If you count from this side, 1, 2, 3, that means in 3 there is a CH3 group. There is no problem at all. You will count from this side or you count from this side. That means here 1, 2, 3, 4, 5. But again you see here the longest chain that is having 5 carbons, so it is pentane. What is the name? Pentane. In 3 position, that is a methyl group, so it is 3-methyl pentane. 3 position methyl group, and M is the capital, and there should be no gap between methyl and pentane. So what is the proper name, correct name? 3-methyl pentane. This is the correct name, because 1, 2, 3, 4, 5. 5 is the longest chain of carbon that is having alkene group. That is why it is called pentane. In 3 position there is a methyl group. That is why it is called 3-methyl pentane. Now here you can see here 3 structures are there for the isomerism in hexane. Again also I will proceed other 3 structures. 2 or 3 structures we are going to try how to write other isomerisms of hexane. So here this is 1 and hexane, second 2-methyl pentane, third 3-methyl pentane. Then we will see other structures. Hexane I told already 2 isomerisms. Now third one 2-methyl pentane. Now you can see 1, 2, 3. In 3 position there is methyl group, and here CH2 CH3. So here you can observe first one CH3 and last one CH3. In number 3 there is a methyl group. So you can write from this side also 3, 4, 5. The long chain is 5 carbons, so it is pentane. Then come to here, that is 2,2-dimethyl-butane. What is meaning here? In 2 position, that is 2,2-dimethyl, 2,2-dimethyl-butane, because 1, 2, 3, 4. So it is the butane structure. In 2 position there is methyl group. In 2 position there is a methyl group. So it is 2,2-dimethyl-butane. Then come to fifth one. That is in 2 position there is a methyl group. In 3 position there is a methyl group. So what is the name? 2,3-dimethyl-butane. 2 position, 3 position, there are 2 methyl groups, so it is called 2,3-dimethyl-butane, because butane, that is the long structure, that is 4 carbon, that is butane, and so it is 2,3-dimethyl-butane, and it is 2,2-dimethyl-butane. Not only position change, here 2 position and 3 position there is methyl group, here only in 2 position there are 2 methyl groups. So here the isomerism of hexane is completed. Now we will see here what is the difference between propane, butane, pentane and hexane regarding chain isomerism. Here propane, butane, pentane, hexane, they also chain isomerism, but here propane no isomerism, and here butane gives 2 isomerism, and pentane 3 isomerism, and hexane having 5 isomerism. That means here I hope it is clear to you the isomerism of hexane, and hope you will subscribe my channel B.L.DASH short and sweet in chemistry, and hope also you will like and share my channel. And thanks for watching my video that is about hexane. And here I have completed the isomerism in butane, pentane and hexane. Thanks again to all.